Hey guys, my name is Shashank Kalanathi, and I'm a data analyst working out of Seattle in Washington in the United States. Today we're going to be going over SQL for Data Analysts, which is a course I put together for you guys, completely free, where in less than an hour, I'm trying to get it to 45 minutes, I will teach you most of what you need to know in order to get started using SQL, at least for an entry-level job. We're going to be really focusing on the querying in SQL, and then I will probably put in like creating tables and stuff like that and manipulating databases in a separate video because I believe that those two skill sets are not necessarily necessary at the same time. Or if you're going for an interview, I am yet to give an interview or take an interview where I had to manipulate databases and stuff in the interview. It was mostly about querying. So let's go ahead and get started. In the description below, you will see these notes that I put together for you guys that you guys can see, like, they work on your phone. You can print them out as a PDF, view them on your iPad. They use the app called Notion. Totally amazing. And I also have a Google Drive connected at in the link below that has the database that you have to download in order to do this lesson. So I'm giving you guys a database so we can get started. All right, so 45 minutes. So when this thing says 10 a.m., I'm going to see if I can get this done by then. So you may have heard SQL or SQL. No one really cares how it's pronounced. Basically, it stands for Structured Querying Language, and it is a language used to query, form, and manipulate databases. Now, one important thing to remember is that SQL is, as a language, not the same thing as like Python or C++ or any of these other like programming languages. You can't really program with SQL, nor is it really built for that. And especially when you start doing more advanced transformations of your data, you'll start to see the limitations of SQL and how it can be a little bit difficult to use in order to actually manipulate data in very advanced ways. It's really meant for querying data. But for that, it's absolutely amazing. And oftentimes in a data analyst or a data scientist will combine SQL and Python together or SQL and R together in order to pull the data using SQL from databases and then manipulate it using R or Python. All right, so setting up our environment. So go ahead and download the files, Google Drive in the description below, but also in the notes over here. And we're going to be using dbeaver. So there's two things we're going to be using. We're going to be using something called SQLite, which I'll explain what that is a little bit later. And we're going to be using dbeaver. dbeaver is an open source database manager that can access just about any database out there. I've used it. It's pretty good. It's free, gets the job done. I've had no issues with it. So go ahead to their website, dbeaver.io, and make sure you download the community version. So if you go to dbeaver.com, you'll see that they have like this commercial version. Don't download that one. Download the one at dbeaver.io. That one's free. The website should look kind of like this. So you just go to download, and then I'll just say I have a Mac, so I just download it on Mac using I like DMGs, so I'm going to download it using that. Of course, I already have it installed. And we'll just keep going. Also, there is a data set that we'll be working with that is also going to be available on the Google Drive. Again, Google Drive in the description below. So, structure of a SQL environment. And we'll go over this when we go through the database, but these are a couple of terms that you might run into. When you are manipulating a SQL environment, you will usually tap into a server. So a server is what you're connecting to initially. And we're not going to go over connecting to a server in this video because connecting to all different servers is very different. If you use cloud servers, that's one thing. If you use on-prem servers, on-premise servers, basically, it's a different thing. It's different if you use Teradata or Azure or AWS. And because that's so specific to the actual company you're working at, I'm not going to go over that. And your engineer should be able to help you connect to databases, to servers. Inside servers, you have databases, and databases are basically a collection of tables and schemas that you can use to store data. Normally tabular data. Tabular data, just think about an Excel spreadsheet. That's all it is. It's just an Excel spreadsheet. And that's what a database is. A schema is basically a way to organize a database. So what happens is within one database, right? So we can have like company A database and have a schema for finance and a schema for supply chain and a schema for I don't know, like store operations or something. And those schemas can each have tables inside them. Now, different companies may choose to organize their databases differently. What I've seen a lot of companies do is that they'll have like an analytical database, which if you're a data analyst, that's probably what you'll be interacting with. And in that analytical database, they'll have different schemas for different sections of the company. Other companies I've seen who aren't as far in their analytical transformation will have a different database for every, or a different server really, for every team out there. So finance will have their own server, and as an analyst, you have to go and grab the data from there, put it together from data in another server. And if you want to know what a lot of a data analyst work is, in many companies, that can be what it is. It can be running around looking for data inside different servers, putting it all together, and creating a dashboard or creating an analysis out of it. But which is not the most fun part of the job, but hey, job security. All right, so different database types. So I'm talking about SQL as if it's a standardized language, but SQL really is not a standardized language. Well, okay, it is a standardized language, but in practice, the SQL databases you'll be interacting with are going to be created and run by major corporations like Microsoft, Oracle, Amazon, stuff like that. And each of them will have their own little flavor of SQL, where they'll like sprinkle like little differences and little features on top of the language in lieu of standard SQL. That being said, don't worry too much. What the stuff we're going to be doing in this video should work on just about every database out there. And if it doesn't, then what you can do is you can just look up documentation on, for example, if you're using Microsoft SQL Server, you can look up, okay, how do I do this thing? Or if we have like a function called like, or like a command called limit, right? Limit in Microsoft SQL Server. Look that up on Google and you'll be able to find the different variations for different databases out there. Me personally, I have only extensively worked with MySQL, SQL Server, and Oracle database. I've always wanted to use Postgres, but because Postgres is open source and very advanced, has a lot of really cool features inside it. I really like it, but I have never been able to use it because no company I've had and no client I've used has ever used, or no client I've ever had has used PostgreSQL. All right. So let's get started. So first thing you got to know about SQL is that you have different data types, right? And the different data types are basically used to, or let me back it up for a second. I think actually, oh, sorry, I forgot to go over tables over here. Sorry for the confusion. So tables, think about it as an Excel spreadsheet, right? So you have an Excel spreadsheet and you have your headers and you have your column, right? And in your headers and your column, that's how you organize a SQL table. Now, in each of those columns in a SQL table, you have to define a single variable type. So that can be like your basic variable types are like text types, basically used to store text. So like my name, Shashank, that is text, S-H-A-S-H-A-N-K. Or you can even store numbers as text. So for example, you can store the number 1 as text if you want to. And depending on what you're doing, you may or may not want to do that. So for example, zip codes in America. So zip codes are the equivalent of postal codes in other countries. In America, we have a 5-digit number that every address has. That is your zip code, and the Postal Service uses that to deliver mail to you. Now, what happens is that number can start with a 0 if you're on the East Coast of the United States. And what happens if you have a leading 0? So, for example, like I'm like, this is that's probably a zip code, or yeah, this would be a zip code, for example, in the U.S. This is probably a zip code somewhere in the country. If you stored this as a number, then SQL, the database would get rid of that leading 0. And I cannot tell you how many times I've had problems with people storing zip codes as numbers and then me having to add a 0 at the beginning of everything. So this is an example of where you'd want to store a number as a text. Because, for example, you can't perform math on zip codes. Like 75063 plus 01213 zip code doesn't mean anything. So that's a problem, and especially in this case, you have the leading 0, which you have to worry about. Social security numbers might be another what do you call it? Another thing that has leading 0s inside it. I'm not exactly sure if they do or not. So that is an example of why you might want to store numbers as text if you want to keep those leading 0s, for example. And then when you have the text types, you'll have like these different. You might see like char, varchar. Usually varchar will be passed with like a number. So char basically means a character, and it's like a fixed length, basically meaning every single variable in that column has to be of the same length. So like say 5. Varchar means variable characters, meaning that it can be as long up until the length of this. So you can have up to 255 characters. This is another thing you might have to worry about in databases. I actually was recently making a database for a client where I used the default varchar 255 for a notes column, which is a bad idea because people's notes can be easily over 500 characters long. So I changed it to varchar 1000. Because I do want to constrain the amount of space that the data is taking up in the database. Next, you have numerical types used to store numbers. So you have like integers, floats. Floats just mean decimal numbers. Real numbers, numerics, bools, booleans. Booleans basically a true-false value. 0 usually means false. 1 usually means true. So booleans are usually 0 or 1. And then some booleans are even like 0, and then any number that's not 0 is a true value. So that's something worth remembering. Date types, we are not going to go over dates in this tutorial because dates deserve their entirely own video. In every programming language and everything to do with computers, dates deserve their own video because they're such a freaking mess to deal with. Unfortunately, we have to, though. And then binary types, where what happens is sometimes if you want to store like an entire file inside your database, you can crunch it down to binary, which is basically just ones and zeros, and then store that in a column. And then whenever you need to get the file out again, you pull out the data and then you put it into a special program like some Adobe program or some Microsoft program in order to actually read the data. So you might wonder why I had these like these subtypes underneath it, and the reason is because you remember how I said like these major companies all have like different databases. Well, they all call these things different things in their databases, and it changes from database to database. So the important thing to remember, in my opinion, and again, remember this is like a beginner's course, right? The important thing to remember is that you have like text types, numerical types, date types, binary types. Those are like your big data types you'll be messing around with for the most part. All right, so let's get to actual querying. So let's go ahead and install dbeaver, come back, and after you install dbeaver, it should look something like this. Now you'll see mine has these 2 folders over here. These are just other databases that I work with for my actual full-time job and my consulting work. So of course I hid that stuff away. So yours will actually be blank over here. So let's go ahead and click on this connection button over here and then go down to SQLite. If you don't see SQLite over here, then go over here and then you'll probably see it like down here somewhere. And you can see like the billion databases you can connect to in dbeaver. It's pretty tight. All right, SQLite. And then under path over here, go to browse and then open up that file, SQLite test.db, that I put in the Google Drive for y'all. Open, and then click finish. And then when you do this, what happens is it might download like a driver and everything. So just let it download whatever it needs to. And then click it open and you'll see, okay, so we have a database right over here. And then we have our tables, views, indices or indexes, sequences, table triggers, and data types. So we're going to only be focusing on tables today. So go ahead and expand that. And you'll see you have dataset 1, table to join, and table to union. So we are going to go through all of this stuff right now, and we're only going to be focusing on dataset 1. So what I want you to do is right-click dataset 1, and then click on, let's see, oh, sorry, my bad. Don't click on dataset 1. Right, you have to do this at the database level. So right-click SQLite database, go to SQL Editor, open SQL Script. All right. So here we go. So let me go ahead and put this over here. And then we'll go ahead and we'll take these notes, put them over there. Should fit everything. Okay, cool. So the first thing we're going to do is we're going to go ahead and take a look at the data. So how do you look at data in SQL? Well, the first thing you do is you type in select star from dataset 1. Yeah, that's about it. And then I put a semicolon at the end, and we'll explain this in a second. And then click on that play button. And you'll see we get a view of our database over here. So in fact, I could probably close this. Give us a little bit more room. There we go. Now let me explain what we did over here. So what we did is, a lot of times SQL queries actually make sense to read from the bottom to the top, not the top to the bottom sometimes. So we looked at dataset 1, which remember was a table inside the, yeah, you can see over here, dataset 1, that was a table. So we opened that, we said go into, so from dataset 1, select. So select meaning pick out, and this is where we specify our columns. By putting a star over here, I'm telling it to select all the columns. And I didn't limit any rows or anything, so we have all the columns, we have all the rows. But what I can also do is I can specify, for example, only open up destination. Destination. Come on. Enter. There we go. Autocorrect. And then hit this play button over here, and you'll see it only brought up the destination column. Or I can do destination and passenger spelled incorrectly. Not my data set. And you see, we brought in the passenger column. So awesome. You've already started querying rows and stuff. This is like your bread and butter. This is your like most basic SQL, okay? So, and the semicolon is how you like end a SQL statement. So depending on the database engine you use, it may require semicolons, it may not. I just recommend always using semicolons. So the first one I used to use, Exasol, did not require semicolons at all. But then I started working with more complex SQL code, and I was like, okay, you know what, I should probably start using semicolons. So I should specify, I learned all of this stuff informally, so there was no like formal education behind any of this stuff. So that's to tell you guys that, you know, if I can learn it, anyone can learn it. All right, so the next thing you might realize that we just pulled all of our data all at once. There's 12,000 rows in this data set, which isn't too many, but you may have databases that have like 1 million rows in them, 2 million rows in them, even 100,000, right? That's too much data to pull all at once sometimes. So what you want to do is you want to limit the amount of data that comes in. So after we have our select statement and our from statement, I can add limit over here. Now, what is that going to do? That's going to tell us how many rows we should limit it to. So let me limit it to 10 and hit that. And you'll see we only brought in 10 rows. And what I recommend whenever you like are opening up a new database and you just like want to like take a look at what's inside it, do a query like this. Select star, limit 10. That way you're not like just sitting around waiting for data to populate. And yeah, you want to use limit a lot because it's good practice not to query too much data when you don't need it, because oftentimes you'll be sharing a database with like, 30 other people or 30 other analysts, and one person pulling a bunch of data or querying or inserting a bunch of data into the database can slow it down for everyone. And depending on your company, your engineers may or may not give you more compute to deal with that. So I would highly recommend using functions like limit and commands like limit in order to limit the data as much as you can. Always bring in as little data as you can. That's my philosophy. Never bring in significantly more data than you need, because it'll just slow everything down. All right, so the next command I want to show you guys is the distinct command. This is basically a way that we can see what are all the unique values inside a column. This is another great way to explore a data set. So I kind of listed these commands in the order of how I would like go through exploring a data set myself that I'm like completely unfamiliar with. I started a new job at a major American retailer in January, and this is like how I explore data sets myself. All right, so let us go ahead and remove this limit over here, and let us select distinct, and I want to see the distinct passenger values. And you can see we have 4 different passenger values. So, it's a 12,000 row data set, but now I can see the 4 different values that we're looking for. The next one, okay, this is a good one. So this is, so let's say we want to get all of the passengers that only say alone with them. And I don't even know what this data set is. It doesn't even matter. This is just a lesson on how to query data. Alone, right? So what we can do let's say we want to filter data, right? So let us go ahead and do select star again, right? Remember, select star is how we select all of our data all at once, okay? And then after the from, I can put in where. So select star from dataset 1, where passenger equals, let's say, alone. And you want to use single quotations, because in databases, double quotations can like refer to a column. Oh, another thing, also like a lot of databases will like specify columns with brackets like this. Depends on the engine you're using. In my opinion, it's good practice to use brackets as much as possible. But like honestly, if your engine doesn't require it, I wouldn't do it. What did I do wrong? Select star from dataset 1 where passenger equals alone. Interesting. Oh, you know what? Maybe I may have like selected something on accident. So like I think if you do that, like just select a couple of characters and then hit play, it'll like run that code specifically. So that's probably what I ended up doing. And you can see we only have passengers that are alone now. So cool. We've now learned to filter data. And if you want to like chain the other filters, right, you can also do like and weather equals sunny. And, you know, we won't see a change over here. You know, maybe a better one would be and destination equals home. And you can also use ors. So for example, I can type in where passenger equals alone or destination equals sunny. Or home, sorry, destination equals home. And you will see, let me see if I can find a good example. Passenger equals alone or... Maybe that wasn't a great example. Let's see. What is another thing I can do? Or time equals 2 p.m. maybe. Okay, yeah, here's a better example. So now what it's doing is that it's looking for any row where the passenger is alone or the time is 2 p.m. So in this case, you'll see the time is 2 p.m. the time is 2 p.m. here, but the passenger is not alone. Or in this case, the passenger is alone right here, but the time is 7 a.m. So you can use ands and ors if you want to like filter through your data. And then say we want to order our data, right? I want to order it by time maybe. So I can then go down here and I can type in order by, let's say, time, ASC. There we go. Okay, so it seems that dbver is sensitive to having a white space over there, so be careful of that. Okay, cool. And then ASC, what that means is that means ascending, which means that it'll like count up from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that order. Where so for example, like time, because this is a string, 10 a.m. is one of the first strings you'll get, and then you'll see as we go down, we have quite a bit of data over here. But if you go further down, there's a lot of data here. Oh yeah, there's like one or like 10 p.m. showed up. So we're ordering by time. And then I can also do DESC, and that is descending. And you'll see it'll order it in the exact reverse order, from top to bottom. Oftentimes I'll actually end up using descending because I'll be like, okay, stores by revenue, descending, you know, because I want to see which stores have the most revenue. But you might want to use ascending too. So that's your order by. And then let's make this script a little, or you know, we'll leave it as is for now. Aliasing is something that's used all the time. So what happens with aliasing is it's basically you're changing the name of these columns. So for example, let us get destination, passenger, and time, and then we'll say time as the time. And then a good way to format this is to have an enter between, or a line space between each one. And you'll see now time is called the time. So aliasing basically just gives a new name to the column that you want. You can also alias data sets too. For example, over here, yeah, you can also alias data sets if you want to also. For example, over here, I can call this D, and then now I can refer to this data set as D whenever I want to. We're going to be using that a little bit later, so that's not useful right now. And then comments. So comments are super useful in any language. Just it's a double dash in SQL. Hello. And what happens is you'll notice it doesn't affect my code at all. Now you can also use it to comment out a line. So oftentimes if I want to like test out a couple of stuff, I'll like just comment out the line. So by putting a double dash before that destination, you'll see it'll drop that destination column now. That's not there anymore because I commented it out. When you comment something out, basically you're saying, hey, this isn't code. This is just some like random gibberish I'm putting together. So, and I think, okay, so dbeaver doesn't do it. So a lot of code editors will let you hit command / or control / to comment out lines one after another. dbeaver probably uses some other standard. All right, so let's go ahead and start doing aggregation. So aggregations are where we really start getting spicy with our data. So what an aggregation is an aggregation is basically just a way of grouping your data by a certain column. So let's just go ahead and try and see what happens. So we will save this query over here. We'll leave that as is, and then we'll go down here. And then we'll say select destination, and we'll just leave it as is for now. Select destination from dataset 1. And you'll see dbeaver actually adds this little alias for me already. So I'm going to leave that as is. It's actually a really useful feature. When we start getting into joins, you'll see why that's so useful. So select destination from dataset _1, and then group by destination. Let's hit our little semicolon over there. And you'll see this looks kind of like what we did with distinct. Basically what happens is it took all the duplicates of destination and just like crunched them into one cell, one record. So you're like, Shashank, why is that useful? What does that matter? Well, let's go ahead and put in another value. I think another good one would be temperature, right? Okay, so what do we have here? So we had a column in that data set called temperature. Let me go ahead and show it to y'all. And you'll see that I'm typing everything in uppercase, but Sql is like not at all picky about this kind of stuff. So like Sql doesn't care about spaces between lines. Normally, for some reason, dbeaver seems to care, but Sql doesn't actually care. It doesn't care about uppercase, lowercase, none of that matters. I think uppercase only matters with column names, but otherwise you can like, I mean, you know, I can even write it like this if I want to. You know, doesn't matter. Select star from dataset 1. Yeah, because what happens is SQL just feeds in the entire query as like a single line. So even if you have like 1,000 spaces in between your stuff, it'll just give it to the engine in a single line. So like space it however you want to. Just readability is what I'd say is pretty important. So we have a column over here called temperature somewhere. There we go, temperature. Which is basically, you know, I mean, it's some temperature. I don't know what it means. But the point is it's a numerical column, and you can see because dbeaver tells us right over there. So what I did over here when I ran this query, select destination, ABG temperature, from dataset 1, group by destination. I said, okay, take every destination and only give, and like group it by that. And then find the average temperature for that destination. This is a tremendous thing that you can do in SQL that's like super cool, and it's one of the big advantages I'd say like over, it's one of the things that's like super easy to do in SQL versus like, for example, if you wanted to do this in Excel, it could be a little bit more difficult. But then what else can we do? I can also take the sum of the temperature. I don't know why I'd ever want to do that, but I can. So, you know, there's 199,060 degrees Fahrenheit for all the home records across the entire database. I can even take the count. How many records are there? There are all these different ways to aggregate numerical data. Okay, so it looks like there's 3,237 home records, home temperature records. Temperature records, my bad, yeah, temperature records. That have the value home. And then 6,283 that have the value no urgent place. And then 3,164 that have the value work. So you have these different ways of aggregating your data. We can even do count and then add a distinct over here. So like this is the cool thing about SQL, right? You can kind of just like mix together all this stuff, make your own little recipe. And what that'll do is that'll give me a lower number than count. Yeah, there's only three different temperatures, three distinct temperatures for every each of these categories over here. And if we look at the data, we can see what those temperatures are. So what we're doing over here is we're doing something called aggregations. We're taking data and we're aggregating it. Basically, we're crunching it down from individual records to something smaller and more useful. So now I know in the home, the average temperature is 61 degrees. In the no urgent place, the average temperature is 65 degrees. At work, the average temperature is 59.9 degrees. I'm guessing that's Fahrenheit. That seems like it would be way too hot to be Celsius. So aggregations are a tremendously powerful tool. Now we can even do group by, let me add, like, for example, time here, and then add time there. It's probably another just highlighting. Oh, sorry, I forgot this comma. You see there's no comma between the time and the average. You need a comma between every column that you're calling. And now what happens is you'll see in the home, we have a value of time of 10 p.m. and 6 p.m. So that means that all of the home values only have a value of 10 p.m. and 6 p.m. At work, you only have 7 a.m. and no urgent place, you have 10 a.m., 10 p.m., 2 p.m., and 6 p.m. And we can get the average temperature for the home at 10 p.m., for the home at 6 p.m., for the no urgent place at 10 a.m. So you can start making like bigger and bigger aggregations to like get more granular with your data. If you're looking at stores, for example, right? Okay, what is the average revenue last week for sales in District 1, District 2? How many stores are there? Okay, what about Region 1? Region 1 with District 1, stuff like that. And we can even start chaining together all of our commands now, right? Like this is where SQL gets really exciting. Let's see, we got a group by over here, right? There's something I wanted to do. Check this out. Where time does not equal. So does not equal can be done one of two ways. It can be either an exclamation mark equals, or it can be done like that. I think this is the one that more databases recognize, if I'm not mistaken. And I want to get rid of all the 10 PMs, for example, right? Watch me. You'll see that 10 p.m. went away. I think there were two records that said 10 p.m. and they both went away. We're chaining together commands now. Oh, okay, wait. I want to order this by the time. So there we go. Now our data is ordered by time, and now you can you're making a report that you can now send to anyone that's asking you for this data one by one. We're like putting these commands together. One important thing to remember is that you can't just put whatever command wherever you want. So for example, you'll get a syntax error, right? Because the group by has to come before the order by. And actually what I think I'll do is I will put a sample query at the end of the end of this notes page that kind of has like, okay, here are all of the, here's like a mega query. And here, this will give you like an idea of like the order that everything goes in. So actually at my desk, back when I was first learning SQL, I had like this like a sample mega query that had like every single command inside it. That way I knew what order stuff came in, because like you can't just put commands in whatever order you want. Okay, so as you can tell, like aggregations are super exciting to me, because this is the kind of powerful stuff that like separates a lot of people that know how to use SQL from like regular business users who may not know how to use SQL. It's the ability to aggregate data very, very quickly and like, pull insights out like that. All right, so you got your count distinct, sum, minimum, maximum. It'll give you your minimum and maximums. Pretty self-explanatory. Having, okay, so having is interesting. Okay, so this is a little bit difficult to explain. So what happens is sometimes you cannot use where. Let me like run this first. You cannot use where when you are when you are trying to filter out your data using a group by, in which case you will use a having. So for example, I can go over here and after the group by, I can say having occupation equals student. And it looks like there are just no records for that. So let's get rid of that. We'll just comment it out and then run it again and we get back to our old data. So That's your basic aggregation. So now we've learned to select data, we've learned to aggregate data, and then let's go to combining data. So you'll notice that actually this data set over here, where is it? Oh, here it is. I have something called table to join and table to union. So table to join is so let's work with unions first. Unions are a lot easier. When you union data, literally all you're doing is you're taking your like table, right? It looks like this. It's a rectangle, looks like this, and you're stacking it on top of another table. So you're combining two tables vertically like that. That's all a union is. Nothing more to it. So when you union data, you can simply use, let's go ahead and bring in table to union. So what I can do is, it's pretty simple. I can just do select star from dataset 1D, and this is, oh, actually it'll be more useful in joins. And then union, whoops, select, or sorry, union, and then we just bring in the table we want to union. Table to union. Oh, sorry, whoops, forgot my, there we go. And we brought in our table to union. So now these two tables are stacked on top of each other. Now, how do we know it actually worked out? Well, if you remember, let me go ahead and this is a good practice. Every time you run a query that is a little bit complex, you should check and make sure that you actually pulled the data you wanted to pull. So this is how I can check it, because I know these data sets because I created the union one, and I got the other one from UC Irvine. Destination. Okay, so check this out. When I just pull the distinct values of destination from dataset 1, I get these three: no origin, place, homework. So remember, those are the ones we had. And if I take this, and let me just show you guys something called a subquery over here. Select distinct. So what I'm doing is I'm saying selected from this subquery over here. So this is just subquerying it. Subquerying is super useful if you want to like stack different queries on top of each other. So like, you know, here's one query that we did, and then we're gonna select from that query, from that table we just created. You'll see now we have union over here. So we stack these tables on top of each other, and now we have like union there. And there's some stuff that you have to remember when you like do like unions and joins and stuff like that. I think I might put it in my next video where I talk about like some of the gotchas and stuff with what do you call it? Sql. Because actually, you know what? Let's just go through it right now. You have union and you have union all. So what union all does is, okay, cool. Yeah, that worked. So union all will actually, and you should probably be using union all. Union all will stack all of your data together and make sure that duplicates are allowed, and which is usually what you want to do. You just want to like stack the tables on top of each other. Union, just union, will not let you do that. Yep, just had to make sure that was correct. Worst thing would be to give you guys the wrong information. All right. So next you have something called join. So joins join two tables horizontally like this. So like, let me show you guys what we might want to do. So select star from table to join. And you'll see it already gave us an alias TTJ. And let us run that. All right, and you'll see we have time and we have part of day. So part of day is actually it's not a column inside our dataset 1 dataset. But what I want to do is I want to map each of these times, which is time is in our dataset. I want to map that afternoon, morning, evening, morning, night to our data set. I want to like add that information in horizontally. That's where I would use a join. And there are 4 basic joins that you can use. We're going to go over them pretty quickly. So I actually go over this in much more detail in my Tableau course. So I have a Tableau course, a Python course, and then this course. I think if you take all 3 of those courses, you are more than and you can do what's inside them. They're all free. You are more than qualified to handle what's coming to you as a data analyst, at least as an entry-level one for sure. And I would say you can even get into like the senior level with that level of information. With practice, obviously. You have to be like proficient in this stuff. Okay, so you have like your inner joins, left joins, right joins, and full joins. So what happens is when you combine 2 data sets like this, right, you have a left set and, let's see, would this be left for you guys? I guess this is left for you guys. Okay, you have a left set and you have a right set, right? And when you combine them together, you combine them on one column, and then an inner join will basically say, okay, all the values that are common between these 2 between whatever columns we specify, only keep those. Get rid of every other row. And then a left join will be like, okay, all the values are common between the 2 columns, and every value from your left-hand table, keep those 2. And then a right join is all the values that are common, but are in the right row, keep the right column, a right table, keep those. Basically, don't drop anything from the right-hand side. And then in a left join, don't drop anything from the left-hand side. And then a full join. And you'll mostly be sticking to left and inner joins. As a point of practice, I rarely use right joins myself. And what happens is when you do a join, I have like a better explanation in my notes. I highly recommend going through the notes and going through that explanation. I don't want to spend too much time on it because we are keeping it really simple here. We're just going to be doing one join. There is something to worry about with a duplication error, which is not necessarily an error. Sometimes you do want to duplicate your data. Actually, in this case, we do want to duplicate our data because I want this afternoon to duplicate for every 2 p.m. over there. There is basically like tied to every 2 p.m. there is. The notes have a much better explanation than I'm giving right now as to like how the joins actually work. And my Tableau course and my Python course, I go into a little bit more depth in those because those are a bit longer than this is. So let's go ahead and do, or you know what, select and time is actually not a good name for a column because that's a SQL function. So another pro tip, you want to avoid naming columns like other SQL functions. So select destination time from, let us say, dataset 1, left join, table to join, from, or sorry, let's on d dot time equals ttj dot and this is where you'll start seeing aliasing actually matters. All right, so let me just run this and then we'll go through it. So you'll notice that like there's a time column in this table. There's also a time column in our dataset table. So how do I differentiate between the two? And that's where aliasing comes in. By giving this an alias over here, I can say d dot, which means go to table D and find the time column in that table. Now I could also do dataset _1, and that would be just as valid, but you know, use the alias, it's way easier. So d dot time and then ttj dot part of day. So like d dot time means what it's saying is don't get the time, don't bring in the column of time from the ttj table because I don't need 2 columns of that. And then what we're doing is we're telling it, okay, select these columns and then from dataset 1, and then left join, meaning like bring it in from the left hand side, or sorry, this table over here is the left table, and this table over here is the right table. Left join that data on where d time equals ttj.time. And what you'll see is we've added a new column over here with the information that we need. So joins are wonderful, and they're a great way of like really adding more information to your data. Unions are a great way of adding more records to your data, so like more like instances of like data you already have. Joins are a great way to add new columns and new information to your data. Unions add records, joins add columns. And then we have like inner, outer, right joins. In this case, an inner join or a right join, or an inner join or a left join would work the same way, just because of the way I engineered the data set, but that doesn't necessarily happen. Next, we're going to go over subquerying. So, I already showed you guys subquerying, advanced filtering. Oh, okay, so this is interesting. So you can filter in some really interesting ways. Star from data set 1, where weather, like, sun, percentage sign. And you'll see it brings in all of the weathers where it says sunny. So what this percentage sign does is it says like any characters that come after that sun, the sun, include all of those. And then we use like over here. So you can combine the like operator with these wildcard operators over here. And you can bring in like sunny. So for example, like if I want to bring in like, there's not a great example in this data set, but like any PM time, right? Check this out. Normally, remember we had like 5 different times I'd have to specify each one. Let's not do that. We're lazy. We're going to do it this way. Or skilled, What classifies a PM time? It's the fact that there's a P inside it, So let's do 2 percentage signs and put a P in the middle. And you'll see we brought in all the PM times, none of the AM times. So this is where you can use something like the like operator in order to... forgot my semicolon, in order to bring in the data. Between is another one. So between will basically say like, it's especially useful for like numerical operators. It'll say like bring in any data that exists between these two values over here. In is another really interesting one. So in is interesting because I've used like these lists can get really long. Sometimes you have like, I've had an issue where like I've had stores that I need to like specify. I only want to include stores like 1 through 20 instead of like 1 through 1,000, right? And then what happens is I'll like make a big list of like 1 through 20 and then like paste that in there. So select occupation from dataset 1 where occupation in, sales related or management. So what in does is basically you create a list like this of like, you have the parentheses over here, and then each record is separated by a comma, and it'll bring in any occupation where it says sales and related or management and nothing else. So it's kind of like, instead of saying where occupation equals sales and related, or occupation equals management, or occupation, you can just create this list over here. It's a lot simpler. Ooh, okay, so advanced aggregation. So these are interesting. Okay, so this is where the rubber really hits the road with some of the stuff that we're doing. So let me give myself some white space over here. See if we can get this done a little bit more quickly. So I'm going to copy this. I'm going to show you guys what it does. So what this does is, let's break it down. Okay, so select destination. So that's just a column. Okay, weather. That's just another column. Fine. Average temperature, okay. So we're bringing in the average temperature, but there's no group by. Wait, how am I supposed to get the average temperature without a group by? Remember in earlier, we used this group by over somewhere. This group by over here to say, okay, I want the average temperature by destination. Well, that's what a window function does. So what we're saying over here is we're saying, give us the average temperature by weather, and I'm not going to try and explain, this is a little bit difficult to explain, so kind of like I just copied the syntax. The average temperature by weather, but don't group our data. So basically what it does is the average temperature for rainy, if you remember, was 55. It's just going to attach that to every single row. And then let's see if I can find like something I could. Okay, this was not like the best data set to use. There we go, snowy. You see it turned to 30. Obviously colder makes sense. So what this is doing is this window function is instead of giving you an aggregated result, it will give you the same every single row in the data set result, but it does the aggregation in the background and then brings that into every single row. And it's basically saying, give us the average temperature by weather, but don't aggregate by anything else. You'll find uses for this. This is obviously probably going to be used less than like your group bys, but you will find uses for this. Like it's a good function to know. Another very useful one is row number. where you'll basically see that destination weather row number over, excuse me, it just gives a number for every row. That's all it does. And then you have to give it some order. Rank is another window function. And these are a little bit harder to teach because like you kind of have to have a use case for it first before you have to kind of be like, okay, I need to like do this thing. How do I do it? Before, it makes much sense to do it. So what rank does is it will rank based on this weather column over here. And what happens is it's basically saying rainy was the first record. So every rainy record will be equal to 1. And then, home rainy, my bad. Home rainy is 1. And then the next different record we got was no urgent play. So you'll see it's at 255 over here. So that's 255. And then the next like different combination will be 786, Again, it's kind of hard to show give you guys a use case for this specifically because it's like kind of like you'll find one when you eventually need it. Dense rank is a little bit different. In that instead of like getting the row of the new combination of destination and weather, it just says 1, 2, 3, 4. This is the order that we're dense ranking stuff on. And this is stuff that I think is worth just like knowing about for an interview. You probably won't be asked to do a lot of window functions in an interview. And if you are, there'll be stuff like it'll be stuff more like this one over here, like find the average temperature per weather, but don't aggregate everything together. This is probably what you'll see in an entry-level interview, more so than the ones I'm showing you right now. These are just kind of from a list that I've linked in the notes below of what are just some functions you might want to see. In fact, I probably won't even go over entile. Lag is very useful. Lag is a good one. So this is useful if you want to get like the previous record. So you'll see over here, destination time, lag row count. So row count was actually a column I put at the end of the data set. 1, so lag by 1, basically meaning get the previous value and then put that over here. And then basically if there's no previous value, meaning for the first record, put in 99,999 and then order by row count as lagged count. And then you can even do the same thing with lead. And you'll see it does the exact opposite. Now the first record says 2 instead of 99999. All right, and that's basically it as far as like basic SQL is concerned. I really hope that this class was very useful for you guys. I'm gonna put out more videos on like SQL and stuff. So I'm definitely more of a Python guy. I put more of my work into Python, but these are like the basic functions that I use every single day. There are more advanced functions that you'll use, and then I'll be manipulating tables like create and alter and stuff like that. I'll put that into a different video, but I really wanted this to be a bit of a shorter course. If you are about to take a SQL interview, this will get you a lot of the stuff that you need done for that interview that you will probably be asked to do. So if you have any questions or concerns, please leave them down in the comment section below. If you want to support the work that I do, I put all these videos out for free. Please sign up for my Patreon. I actually have some extra materials over there for my patrons as a kind of incentive to sign up for the Patreon. But thank you guys so much for your support, and I really hope that this was useful, and I hope you guys have a great day.